Sorry. So even after daylight saving, your schedule is going to be the same. It won't change. Okay. So yes, after the daylight saving also, we are going to start at the same time. That means it starts at 8 a.m. Central Time itself regularly for people. Okay, fine. So where did we stop? Yeah. So I guess we were talking about the organization. Hello. Sorry. Can you people hear me? Okay. Sorry. So lost the connection. Okay. So today we'll talk about fetching strategies. Today we'll talk about fetching strategies. So what are these fetching strategies? Let's see. First of all, you see, so far you people saw that trying to fetch records based on the ID. Right? Just a second. Yeah, sorry, yes. There was some issue with the connection. So, yeah. So you see, we were trying to fetch the record based on the ID using get method, right? So actually, we got another method called as load, which we can use to fetch the records. Similar to get, we got load method. Yes. So, sorry, the get method and load method, you see, we can use it for the same purpose to fetch the records based on the ID. But is there any difference between these two methods? Is there any difference between these two methods? Yes, I can say there is a difference. So hope you're able to hear me, right? Okay. So there is a difference between these two methods here. So what is the difference? I'll make you people understand. So far we have used get method. You will find that get method, when you call the get method, what it does is it will immediately hit the database server, fetches the record, you know, it will execute that query, fetches the record, transforms that record into a product object, and returns that product object reference. Okay, get method. Whenever you call that method, what it does, it will fetch the record, it will straight away hit the database server, it will fetch the record, it will transform that record into a product object, and returns that product object reference. Yes, that is what the get method does. Okay, what about the load method? Load method, sorry, will also fetch the record, but there is a difference. What it does is, load method will not immediately hit the database server. Load method, it will not immediately hit the database server here. Then what it does, the load method, first of all, what it does is, whenever you call the load method, it simply creates an object of that particular type. Simply, it creates an object of that particular type. Yes. And returns that product object reference. Okay, load method, what it does, it will create a product object. In first of all, you see, when you call the load method, you're passing the class name, right? What it does is, first of all, it will connect to the, sorry, it won't connect to the database server. It immediately creates a product object. It will store that product ID in that product object and returns that product object reference. And moreover, that object reference which you're going to get, moreover, the object reference which you're going to get, you'll find that it's a proxy object, I can say. You'll find that it's a proxy object. Yes, it's a proxy object. It is actually a proxy object. So the load method will not hit the database server straight away. It is simply a proxy object Yes, which you got. So when it will fetch that record, product record from the database server, then it will only fetch that product record from the database server when user is trying to explicitly read the data. When user is trying to explicitly read the data from the product object, then only it will hit the database server. I can say it will fetch that product record from the database server. Yes. Okay. So I'll prove it. Okay. Let me prove that it didn't fetch that record from the database server. You see, what I will do is after closing the session, I'll try to fetch this record. After closing the session, we'll try to fetch this record. Okay. Yes. You know, that session is mainly responsible for fetching the records from the database server or interacting with the database server. So if you close the session, then there is no one to interact with the database server to fetch that records. Right? Yeah. So if I do this here, I can say that it is going to fail in this record. It is going to fail in this record here. Yes. Let's see. You see, this is the exception which you're going to get. Just read that last from last fifth line or sixth line. You see the highlighted line here. What it says? It says lazy initialization exception. Lazy initialization exception. It says could not initialize proxy. Could not initialize proxy. So it's told you people it has created a proxy. Yes. It says it is unable to initialize that proxy object. Yes. Okay. Yeah. So if the session is not closed, then there is a possibility to fetch that record. You see, nowhere you'll find a select query executed here. Nowhere you'll find that a select query is executed here. Yes. So let's do one thing. In place of get method, in place of load method, we'll use get method here. In place of load, let's use get method. Yes. So what happens in this case? You will find that the get method will immediately or straight away it will hit the database server. Straight away it hits the database server and will fetch that records from the database server here. It will fetch the records from the database server. So You see, this time you won't find any issues. So I can say that get method always follows eager loading strategy. Eager loading. Get method will eagerly load the records, I can say. It will eagerly load the record. That means whenever you call the get method, it will straight away hit the database server. That means it will connect to the database server. It will execute that select query, will fetch the record, and returns that record here as object. Whereas load method, it follows lazy loading strategy. Lazy loading means until and unless the user won't read that product details from the product object, it won't hit the database server. Until and unless the user won't read the record from the product object, it won't hit the database server here. Yes. Okay. Yeah. So now when we need that lazy loading strategy, which is provided by that feature, lazy loading strategy, which is provided by that load method, when we use that lazy loading strategy, what is the advantage? That's it. So do you see any advantage for lazy loading? So what is the advantage of using lazy loading strategy? You know, the load method here, I can say that it is trying to unnecessarily avoid DB interactions. Only if really user needs the data, then only it will hit the database server, it will fetch the record. Otherwise it won't. Unnecessary DB interactions, you see, you will find that they are avoided here. Unnecessary DB interactions will be avoided if we use load method. Okay. So of course that is going to be an advantage. Yep. Now let's see how the associated objects will be fetched here. What about the associated objects? For suppose, okay, we are using get method, or let's say item. sorry, session dot get will fetch the item records. Say 101. I guess there is an item with the ID 101. Let me check once. Yeah, you see, these are the records which you got. So now you see here, we'll fetch that item whose ID is 101. You know that for this item object you got bits associated. So for an item, generally you can have 0 or more than 1 bit. For an item, there can be 0 bits or more than 1. 0, 1 or more than 1. Any number of bits can be associated to that item object here. Any number of bits can be associated to that item objects. Yes. So now that associated bits, the associated bits, will they be fetched eagerly or lazily? That is what you need to know. The associated bits, will they be fetched eagerly or lazily? Okay, let's see. Just a minute, please. Just a minute. Sorry. So, what do people think? You just give me any answer, don't worry. So, the associated records, see item objects which are associated to this, sorry, the bid objects which are associated to this item, will they be fetched immediately when the item object is fetched, or hibernate, will it fetch the bid objects associated to this item only if the user is trying to read them? Yes. Guess whatever it is, no problem. It will lazily load. Okay, good. Why? What's the reason? It will lazily load. Huh? Okay, but why? Come on, think about it. No problem. Why it is going to lazily load? You know what? You gave right answer. Your answer is right. It will load lazily itself. That means it will fetch that associated bit objects only if the user is trying to read that associated bits. Otherwise, it won't fetch them. Otherwise, it will not fetch that associated bit objects. Okay, but why? What's the reason? Okay, I'll explain it. But before that, let me show you people this. Okay, you see, if they are lazily fetched, that means after closing the session, if you are trying to read that bit objects, you will not be able to get them. Okay. Uh, yeah, initially it creates a proxy, I do agree. Yes. If they are lazily fetched, you will find that once the session is closed, you will not be able to read this associated objects here. Before the session is closed, yes, you will be able to do that. But once the session is closed, then it is highly impossible. Okay. You see, I'll try to read the associated bits after closing the session. Set of bits. Bit dot get ID and price. Okay. So let's see what happens. I'll run this code. So after closing the session, it won't be possible to fetch that associated bits if it is lazily loaded. Yes. Okay. Yeah. Fine. So it says fail to lazily initialize collection of role. Could not initialize proxy. You see, but within the session context, before the session is closed, if you are trying to fetch the bits, okay, now this will be possible. You see, even in this case, definitely the records are fetched lazily itself. You see, until and unless you try to fetch the records, session is not going to fetch them from the database. Session is not going to fetch that associated bit objects from the database server here. Yes. So, but you got the session now. That's the reason why it will definitely fetch the records. If the session is closed, then it's not possible. But the session is fetching this records, associated records, only when you're trying to read that associated records. Otherwise, it won't fetch them. First of all, is this point clear for you people, all of you? all of you. So is this point clear for you people? So hope everyone got it. Yes. So this is important. So now the other point which you need to understand here is why Hibernate follows this lazy loading strategy to fetch the associated records. Why Hibernate follows lazy loading strategy. To fetch the associated records, why is Hibernate following lazy loading strategy here? Yes. Let's see what's the reason here. You know, the reason is to avoid unnecessary loading of objects. To avoid unnecessarily loading of the objects, so it follows this lazy loading strategy here. Yes. Okay, unnecessary loading of the objects. How? I'll tell you. You see, here, just imagine, for suppose, if a user is trying to fetch the records, item records. Let's say for that item, you have, let's say, 5,000 bits placed. You see, for the end users, okay, let's say user is trying to just view the item details. User is browsing through the items in the online shop. User is just trying to read the details. I just trying to browse through the items, and whenever user clicks on an item, let's say the details about the item will be fetched from the database. So, do you really think to this user the bit details also should be displayed to this user? bit details also should be should be displayed or should be fetched for this user. Is it needed if user is trying to just view the item details? What do you people think? Yes, no need. If user is just trying to view that item details, you know, this fetching all the bits and displaying that item details is not at all a criteria. It is not at all needed. Okay. Yes, it is not at all needed. Yes. Yeah. So you see, hibernate, because by default it follows lazy loading strategy, so it won't fetch the associated bit objects, right? By default it won't fetch them. So you see, a lot of memory is saved, and unnecessary DB interaction is avoided here. The records are not fetched without any reason, or even records are not fetched until they are needed. Yes. So this is one of the advantage here, right? This is one of the advantage. Yeah. But for suppose, what if I want Hibernate to fetch the associated records eagerly? What if I want Hibernate to fetch the associated records eagerly? Then what? The associated records. Already we are using get method itself here. If you people have noticed it, I'm using get method itself, not load. So we are talking about associated records. Okay. By default, you see, in case of the associated records, it is fetching them lazily. Yes. Yeah. So I'll show you people. If you want the associated records to be fetched eagerly, eager fetching, immediately when the item record is fetched, along with it, if you want Hibernate to fetch that bit objects associated with the item, so we can configure that strategy also, eager fetching strategy. If you want, you can do that. Yes. So what you need to do is go to the item class. You see, you have this bits reference here, right? Yes. You have got a bit reference here. Yes. So on top of this bits reference, where you have mapped this bit association here in the item class, what you need to do is simply you add this fetch equal to eager, fetch type equal to eager here. That's it. Okay. You specify the fetch type is eager here. That's it. So this indicates that now we want that associated bits also to be fetched eagerly, means immediately. Okay, it should not wait till the user wants that associated bit objects here. Yes. Okay. So you see this time, so immediately they are fetched. You see, even after closing the session, if you try to read the bit objects, there won't be an issue. Earlier we had an issue, if you people remember. After closing the session, if you're trying to fetch the associated bit objects, we got an error. Yes, earlier we got an error. Yes, but this time that won't be the case. Okay, let's see. Yeah. Okay, so hope you people got it. So any questions? Okay, now see in case of one to many, that entities which are on the many side, say the bits are many, so always it will fetch that bits lazily by default. Okay, but you can configure it as eagerly also. So eager fetching is also possible. Yes. You know what? Now we'll see many to one. Sorry, we'll see many to one. You know the association between the product and the supplier is many to one. Just check this. In the product class, we got a reference to the supplier. So this is actually a many to one association. So always to a product object, only one supplier is associated. There will be one supplier object associated. So what do people think? Even in this case, the associated supply records, will they be lazily fetched or eagerly fetched? Will they be fetched lazily or eagerly? Yes. Is the supply details here? What do you people think? Eagerly. Okay, Vani says eagerly. So why do you think Vani, the records are fetched eagerly here this time? No, I didn't specify the fetch type. I'm asking the default fetching strategy. Hibernate by default, which strategy it uses? Eager fetching or lazy fetching in this case? Lazy. You will find that here Hibernate in this case it follows eager fetching strategy by default. In case of many to one association, you see to this product object only one supplier is associated, right? Just one supplier is associated. So in this case, it won't go for lazy fetching. It will follow eager fetching strategy itself. It will follow eager fetching strategy itself. Why? Because just you got one supplier object associated to this product, right? Yes. You got one supplier object, right? It doesn't make much difference if you got one object. Okay? Yes. So if many associated objects are there, then it may make a lot of difference if you use eager fetching. But this time it won't be a big deal here. Yes. Is it clear for you people? That's the reason why Hibernate in this case will follow lazy loading strategy. Yes. Sorry, eager loading strategy here, not lazy. Okay. In case of one-to-one association, what do you people think? Hibernate to fetch the associated object, it follows which strategy? To fetch the associated object, it follows which strategy? I'm sorry. So eager. You see, let's say for example, you got user and address. So the association between user and address is one-to-one association, right? Yes. Okay. It will be eager itself. In case of many to many association, In case of many to many association, what about the associated objects? Many to many. We saw items and categories, right? Yes. It will be lazy itself. Yes. Because associated objects are many, right? Because you got many associated objects, you'll find that. So the associated objects are lazily fetched here. Yes. Lazily fetched. Yes. Okay, fine. So this is about the fetching strategies. This is about the fetching strategies here. Yes. So if it is clear, let's move on. Now we'll talk about transaction management here. Okay. Let's see transaction management. So what is this transaction management? So if you have noticed it here, especially to perform a non-select DB operation, insert, update or delete. So other than fetching, a non-select DB operation. That means insert, delete or update. Hibernate recommends you people to use transactions. Within the transaction context itself, you're supposed to perform the DB operation here. You're supposed to perform the DB operation. Yes. Okay. Fine. But what exactly do we mean by a transaction here? So can someone define what is a transaction? Transaction means what? Okay. So, interaction between two objects. Okay. So that we call it as a transaction. Huh? So I got one answer as interaction between the objects. So any other answer? Any other answer? Just a second. Yeah, sorry. So, you know, there are many ways to describe a transaction. So people will describe it in many different ways. You'll find it. So transaction means you'll find that you'll hear this term unit of work. Transaction is actually unit of work. Yes. Set of TB operations you can say. You can describe the transaction as a set of DB operations considered as a single unit. Set of DB operations considered as a single unit. You know, in a transaction, you may have set of DB operations, select, updates, inserts. There can be set of DB database operations. So that set of operations will be considered as single unit, or we say unit of work here. Especially you see we stress on this point single unit. That means which cannot be further divided, which cannot be further divided. That is what it means. They cannot be further divided. Yes. Okay. So why the set of operations should not be further divided? Because they are related. They are all related. Yes. So for example, consider a transaction, transfer of funds from account A to account B. Okay. So here to transfer the funds from account A to account B. So what are the DB operations which are involved here? What are all the DB operations which are involved? Yes. So let's say transfer of funds, how much? 2000 from account A. So account A's balance is, let's say, 3000 to sorry, account B whose balance is 4000. In this case, generally, what are the DB operations which will be involved? Can you people tell me? So what are the DB operations which are involved here? So first of all, you see, read account A's balance, then update sorry, account A's balance to how much? 1000. So we have to deduct 1000, 2000 from account here, right? Then read account B's balance and update account B's balance to how much? 6000, right? Yes. So these are the set of DB operations which you need to execute. Okay. Okay. Yes. So you see all this DB operations which you got here, set of DB operations, you need to consider them as a single unit. You need to consider them as a single unit. Yes. Which cannot be separated. Yes. Which cannot be separated. Yes. You see, either we need to execute all this DB operations or execute none of the DB operations. Execute all these DB operations or execute none of the DB operations. Yeah, that's true. For suppose you see here, if we execute only the first two, if we execute only first two DB operations here, if you are executing only the first two DB operations. After that, let's say there was some issue with the application. Let's say it couldn't execute the next two DB operations here. So will there be an issue? Will there be an issue? Yeah. So what happens? You see, only account A's balance is updated. The account amount from that account A is deducted. The same is not updated, or it is added to. It was not credited to account B, I can say. That is going to be an issue. So we can't afford to do this. We can't afford to do this here. Yes. So this set of transactions, we should, sorry, set of DB operations, we should execute it as a transaction. It means as a single unit here. We should execute it as a transaction. It means as a single unit. Yes. So let's read more about a transaction here, and we'll try to understand more about the transaction. Yes. Let's see. So we'll see once. We'll take a definition from the online itself. Transaction. Uh, just a second. See, further, you can also consider this. A transaction symbolizes a unit of work, as I told you people, performed within a database management system. That means in database service and all, and treated in a coherent and reliable way, independent of other transactions. So you may have several transactions executing. So each transaction should be executing independent, should not be affecting the other transactions, should not be overlapping here, I can say. They should not be overlapping. They should not be overlapping. Yes. See, it says transaction generally represents any change in the database. You see, these operations, they represent some changes, of course, in the database server, right? Yes. Okay. You know, basically, a transaction will have attributes, properties actually. Transaction properties will be there. So every transaction should satisfy that properties. Okay. Every transaction should possess the properties, I can say. Let's see what are the transaction properties. So you might have heard about it. Yes. They're all related to DBs, database. Yes. The Hibernate is dealing with the database itself, right? Yes. So a transaction in database system must maintain Atomicity, consistency, isolation, and durability, commonly you see known as acid properties, in order to ensure accuracy, completeness, and data integrity. Yes. Okay. Yes. So a transaction should basically maintain this properties. It should possess this properties, I can say. So we say they're acid properties. Acid here, you see, full form acid is full form of acid. Atomicity, consistency, isolation, and durability. Okay, sorry. So whenever you define a transaction, you have to make sure that a transaction basically it will possess this properties. Yes. So let's see how to program it. How pragmatically we can make sure that a transaction will possess this properties. Pragmatically, we might have heard about a theory lot earlier about this transactions and all. Pragmatically, how will you make sure that a transaction has got this properties here? Yes. Sorry. So first, we'll start with atomicity. So atomicity means, any idea? Atomicity. Sorry. Okay. So atomicity means here atomicity property identifies that the transaction is atomic. So atomic meaning, generally you know the meaning of atomic, right? So what is the meaning of atomic? Meaning of atomic is which cannot be further divided, smallest unit which cannot be further divided, right? So that is what atomic means. You know, a transaction should be always treated as atomic. That means which cannot be further divided. So you got set of operations in the transaction, for example. You see, you cannot execute these operations by dividing them, right? Yes, let's say first two operations, first you'll execute them, and next two operations you'll execute later. It is not possible. Okay, yeah, just a second, please. Yeah, I'm sorry. So that is what atomic means. So either all the DB operations should be executed here, or none of the DB operations should be executed. So they should be considered as atomic in nature, which cannot be further divided. So, okay, now how can we make sure that we define the set of operations as a single unit? How can we define pragmatically that the set of operations are atomic and they represent a single unit here? Yes. What you will do? Pragmatically, how can we define or how can we make sure that a transaction is atomic? How can we define the set of DB operations as a single unit? Any idea? Okay, you see, we can define the set of DB operations as a single unit by using or marking them here by drawing the transaction boundaries. How can we draw the transaction boundaries here? This way. Begin and commit. You see this begin and commit especially, so we use them to draw the transaction boundaries which will define the set of DP operations. Which set of DP operations you want them to be a single unit? Which set of DP operations should be considered as single unit here? Okay, which set of DB operations should be considered as single unit? So you see now whatever the DB operations which are wrapped here between the begin and commit, whatever DB operations which you got here between begin and commit, they will be considered as single unit. They'll be considered as single unit here. Yes. This way you can draw the transaction boundaries. Yes. Okay. This way we can draw the transaction boundaries here. Yes. And define a unit, transaction unit. Yes. So is it clear for you people? All of you? Can I have yes or no? Okay, good. You see, Hibernate is helping us in defining a transaction pragmatically. You see, we can use this transaction object here for this purpose. So how can you obtain this transaction object? Yes. How can you obtain a transaction object? How can you obtain a transaction object? Yes, you saw that, right? How to obtain a transaction object? How to obtain a transaction object? You see this statement. So you see, to draw the boundaries or to define a transaction, you need a transaction object, right? You need a transaction object here. Yes. So my question was, how will you obtain a transaction object? You see, this is how you're going to obtain a transaction object here. So in the session object itself, you see, we got this method called as get transaction. In the session object itself, we got this method get transaction. Yes. Okay. So hope you people got it. Fine. Next, what is the next property here? Let's see. consistency here. So any idea about consistency? Can you people talk about consistency here? I'm sorry. Something like resistance of firmness. Okay. Okay. So let's try to define this consistency also. Uh, yeah, what you said, I do agree. Let's have more cleaner definition for that. So a transaction, enforces consistency in the system or in the system state or in the DB state, I can say, ensuring that the end of any transaction, the system is in a valid state. Yes, the system is in valid state. Here, I'm sorry. If the transaction successfully executes or completes successfully, then all the changes to the system have been properly made and the system will be in a valid state. System will be in a valid state here. Yes. And if any error occurs in the transaction, then the changes already made will be or should be rolled back. Yes. System here refers to the database. Okay. We are referring to the database. System means it is nothing but the database itself. Yeah. You know, let's say if the database is in a valid state, that means if there are no issues with the data which is in the database, whatever the data you have in the database, let's say it is absolutely fine without any issues. If a transaction, operates on that system, if if it executes or if it operates, then in that case, if it successfully executes, if it successfully completes the execution, then all the changes to the system have been properly made. You see, if everything goes fine, the transaction will make the changes. The changes have been properly made, and you see, the system is set to be in valid state. If everything goes fine, okay, if you got a database system which is in a valid state, the data is absolutely fine. So if a transaction successfully executes, in that case, the transaction should be able to leave that system in the valid state itself. After the execution of the transaction successfully, okay, you will find that the data should be still in the valid state itself. The data should not be corrupted. Okay, the data should not be corrupted. The data should not be corrupted here. Yes. So that is what we need to make sure always. Okay. Just a second, please. Just a second. Yeah. Hello. Can you people hear me? Yes. Can you people hear me? Okay. Thank you. So, see, for suppose, what if there is some issue with the transaction while it is executing? So, you see, when the transaction is executing, it will make changes to the database, right? To the database system. It makes changes to the database system. Here, you know what? During the transaction, even though if it is not completed, it will make some changes, right? Sorry. That changes which have been made, the changes which have been made, if the transaction, if there is any error occur, whatever the changes which have been made by this transaction should be rolled back. Whatever the changes which have been made by the transaction should be rolled back. Rollback means yes. Rollback changes means here rollback the changes means for suppose the transaction has done any updates or modified any data in the database system. You see, during the execution of this transaction, first of all, the transaction will update account A's balance, right? And then it updates account B's balance. But you see, after the account A's balance is updated, there was some error in the transaction which caused this transaction to terminate. Now you see the changes are only made to account A. So these changes which are done by the transaction during the execution here, before the error has occurred, those changes should be rolled back. That means the changes have to be undone. Those changes have to be undone. Yes. Yeah. Okay. You see, we have an option in the database server to undo the changes before any commit is made. There is an option to undo the changes here. Yes. You can do that here. It is possible for us. In Hibernate, also we can do that. Pragmatically, we can roll back the transaction this way. For suppose if there is any error, that means error means exception, right? If there is any exception while executing this transaction, what you can do is you can add a catch block which will be invoked, right? If there is any exception, you see the catch block will be invoked. In the catch block, you can write the code to roll back the changes. Yes. Okay. You can call this rollback method. Hope you people got it. So this is how we can make sure that the database system state is consistent always. So if there are any issues, the transaction, we should make sure that the transaction will not leave the database in an inconsistent state. In an inconsistent state, I'm sorry. Okay, transaction should not leave the database in an inconsistent state. Yes, that is very important. Always that consistency should be maintained. So before the execution of the transaction, if the database system is in consistent state, after the execution of the transaction also, no matter if the transaction executes successfully or not, it should leave the database system always in the consistent state itself. Hope you people got it. Is it clear for you people? Okay. Isolation, I'll talk about it later. First of all, we'll talk about durability here. First of all, let's talk about the durability. Okay, yes. So a transaction is durable that once it has been successfully completed, all of the changes it made to the system are permanent. So it should make sure that all the changes have been made permanent, so that even if the system crashes, we'll have that data. Okay, how can we make sure that the changes which are done by the transaction are durable? That means the changes are returned to the database permanently or updated to the database permanently. The changes are updated to the database permanently. How can we make sure that the changes are updated permanently? You see, by calling the commit method, pragmatically here, we can make sure that the changes are made or changes are updated permanently to the database server. We call this commit method of the transaction. So it will make sure that what are all the changes which have been done are permanently returned to the file. Yes. Okay. Okay. By calling the commit method, we can make those changes permanent. I can say we can make the changes permanent. Okay. So hope you people got it. Yes. So we got one more transaction property, that is isolation, that we'll discuss. Before that, shall we take a break of 10 minutes? After the break, we'll continue the session for one more 1.5 hour to a couple of hours, however it is possible. Okay. Yeah. So shall we take a break of 10 minutes? Okay. So we'll meet after the break. Yeah. Break for 10 minutes. Yeah, I'm sorry. Okay. So hope everyone is back, and can you people hear me? Okay, good. Thank you. So now we'll talk about the last attribute here, that is isolation. So can you people talk about isolation? Yes. Any idea about isolation? Yes. Okay, to separate something. Yeah. So in this case here, in our transactions, we would like to isolate the transactions itself here. Yes. Make sure that the transactions they execute in isolation, as if they are independent. So when a transaction runs in isolation, it appears to be the only action or transaction that the system is carrying out at one time. If it is executing in isolation, you'll find that every transaction it executes as if it is the only transaction which is executing at one time. So that is what it means here. So we should make that means we should make sure that the transaction basically it doesn't overlap with another transaction. It doesn't overlap with another transaction. You know, if the transactions overlap, then we'll have issues. Okay, if the transactions overlap, in that case, we may have issues. Okay, so if the transactions overlap, what kind of issues you may come across? Let's see. Basically, we call them as isolation issues. Okay, if two transactions, if by any chance if they overlap with each other, then you'll find that you may have isolation issues. Yes, you'll end up having isolation issues. I'm sorry. So what are these isolation issues here? What are the isolation issues? Let's see. We call them as transaction isolation issues. So first of all, the first isolation issue which you will come across is lost update. Lost update. Sorry. Lost update. Lost update. So what is this lost update issue? So did anyone heard about this lost update issue? Is anyone familiar with it? Lost update. Let's see. For suppose, let's say you got two transactions. You got two transactions. Yeah, if they select the same row, that won't be a problem. If they update the same row, uh, you know, and you see, let's see what happens. So for suppose, let's say these are two transactions, transaction A and transaction B. So first of all, say you got a data set here. So this is a data set or a row, you can call it as a row. Okay, a data set or a row. Yes. Now let's assume that here transaction A has updated this data set or row. That is the first operation the transaction A has done. Number one is update. Which transaction is doing it? Transaction A is doing an update. Okay, fine. Now let's say here on the same data set, after some time, the second transaction, that is transaction B, does an update. It also does an update. Update. So now you see both the transactions are not yet committed. Both the transactions are not yet committed. Transaction A is not yet committed. Transaction B is also not yet committed here. Yes. Let's say transaction A, now it does a commit. It does a commit now. That means it commits. And transaction B does a rollback, or I'll say, I'm sorry, just a minute. Say transaction A does a rollback. That is the third. That means the timeline here. You see, and transaction B it does a commit. So important thing to notice here is that both the transactions are operating on the same data set. Sorry, both the transactions are operating on the same data set here. Yes. So first transaction A, see, it does update, and transaction B also does an update. But you see that the timeline here, there is a gap between execution of each transaction. First transaction A updates, next transaction B updates on the same dataset, on the same row. Then you see transaction 3 rollbacks. So when the transaction 3 rollbacks, what happens now? The changes which have been done, you know, by these two transactions will be reverted. They will be undone. Transaction A changes and B changes. You know, after that transaction A, sorry, transaction B, you see it is trying to commit. It wants to commit the transaction here. Yes. It wants to commit the transaction. But you see, before this transaction commits, the first transaction has already done a rollback. Before the transaction commits, already the first transaction has done a rollback. That means the changes which are done by by B are lost now. So the intention of transaction B was to update the changes or make the changes permanent. But you see, before it commits, the other transaction is already rolled back here. That means the changes which were done, now they are lost. Transaction B changes are lost. I'm sorry. Transaction B changes are lost. Yes. So this may happen. So when two transactions are working on the same dataset, you may find these issues here. Yes. So is it clear for everyone? So the issue is it clear? This is the issue. Now how can we avoid this issue? So can you people suggest me how to avoid this issue? Can you people suggest me any solution to avoid this issue? Add one more entity. Entity means you know not a block. Okay, it doesn't work like that. So you will find that here that is where we can use isolation levels. Yes, that is where you will be able to use isolation levels here. Yes. So what are these isolation levels? These are the recommended levels. You will find that basically the isolation levels we can set them on the database side. The isolation levels can be configured on the database side. Yes. We have different types of isolation levels here which we can configure. So now here to address this issue, lost update issue, so we can use an isolation level plus read uncommitted. Read uncommitted. Yes. Read uncommitted. Yes. So what exactly this means? Isolation levels basically they will implement logs on the database, you'll find that so you'll have logs, or we say monitors. So logs or monitors are implemented on the database. Here I can say yes, logs or monitors are implemented on the database. So here, if the database server is set to this isolation level, then it indicates that one transaction may not write to a row if another uncommitted transaction has already written to it. One transaction may not write to a row if another uncommitted transaction has already written to it. Yes. Okay. Sorry. One transaction here. One transaction. One transaction may not write to a row if another uncommitted transaction has already written to it. Yes. Okay. But you know what, here, if there is any reading transaction, it will be able to read the data. Okay. If there is any transaction, if it wants to read the data, so it can do that. But you will find that the writing transaction, if any other transaction wants to write, it cannot. So but any transaction here may read the data. Any transaction may read any row. Yes, there's no problem. May read the row, I can say. So that means if this, you see, we can set this isolation level per connection basis from the Hibernate. Per connection basis, we can set this isolation. Per connection basis, we can set this isolation level. So if you set this isolation level, that means, you see, already, let's say you got a transaction A, you got transaction A here, right? Transaction A, you see, it has done the update and it is not yet committed. So you got an uncommitted transaction which has returned to that row. You got an uncommitted transaction which has returned to that row. Yes. Now you see, the transaction B, if it is trying to write the data, or if it is trying to update that same row, transaction B, if it is trying to update the same row, so it will not be able to do that. It won't be able to do that. Yes. It won't be able to do that. Okay. Yes. So because I can say that the locks are implemented. A writing transaction here, you will find that it obtains a lock here, a write lock I can say. It obtains a write lock, exclusive write lock. Exclusive write lock means it will not allow a shared write lock I can say. It will not allow the other transactions to write the data. It will obtain a lock. It obtains a lock I can say. Yes. It basically obtains a lock. Yes. A writing transaction obtains a lock. So which will not allow write lock I can say, but a shared read lock, exclusive write lock, shared read lock. So which will not allow the other transactions to update this row here. It will not allow the other transactions to update this row. Yeah. So till the transaction commits, it will hold a lock on that row I can say. It holds a lock on that row. Yes. Fine. So is it clear for you people, all of you? So this way, you see this isolation level, sorry, this isolation issue can be addressed. But how to set that isolation level? How to set that isolation level? So isolation level, or as read uncommitted, will help us to avoid that isolation issue, lost update. So if you want to set that isolation level, then you need to use a property here. Okay. So this is the property. Hibernate dot connection dot isolation. This is the property which you got here. Okay. So that property value should be 1. So if it is 1, it indicates that the isolation level is set to read uncommitted. If it is 1, the isolation level is set to read uncommitted here. Yes. Okay. Yeah. Per connection basis, the isolation level will be set here. So any questions? Okay. Next isolation issue is dirty read. So hope you might have heard about a dirty read problem here. Yes. Hope you might have heard about dirty read. Yes. Dirty read. Yes. Dirty read. The second isolation issue. Definitely might have heard about it. Dirty read. Yes. read the data which is not yet committed. Yes, reading uncommitted data. Okay, very good. For suppose, you see, let's say the transaction A has updated a row, and transaction B, what it is doing here, it's not trying to update, but let's say it is reading that data which is updated by transaction A. But the important point to note here is that the data is not yet committed. Transaction A has read uncommitted data which was updated by transaction B is reading uncommitted data which is updated by transaction A. Sorry, yeah, transaction B is reading uncommitted data which was updated by transaction A. Yes. And then you see, let's say transaction B uses that uncommitted data. It uses the data. It has read it. It uses it. And after it is done using it, is committing it. But you see, transaction A in this case it is rollback. It is rollbacking the transaction. It rolled back the transaction. Roll back the transaction. What does that means? That means transaction A has read the data. Transaction A, it has read the data which is not yet committed, and it has used it to execute the transaction to make some updates or changes, whatever it is, and it has committed it. But at the end, you see, transaction A rollbacked it. Transaction B is using it. Then you see the transaction A did not retain the data; it was rollbacked. That means the transaction B has read the data which is inconsistent, which is inappropriate. Okay. So hope you people got it. Yes. Sorry. Yes. Is it clear for you people, all of you? Okay, good. Now the question is, how do we address this issue? How to address this issue? You know, here, in order to address this issue, you need to use read committed isolation level. You got an isolation level called as read committed. So you need to set the isolation level to read committed here. Yes. Read committed. Read committed. Yes. So here what happens? In this case, reading transaction don't block other transactions from accessing a row. However, an uncommitted transaction blocks all other transactions from accessing the row here. Okay. So hope you people got it. Next, we got another isolation issue, that is unrepeatable read. Unrepeatable read. You see, in case of unrepeatable read, you will find that a transaction, when it reads a row twice, each time it gets different data. Each time a transaction reads the data, let's say transaction has read the data twice. Each time it gets a different data. Transaction reads row twice, reads different data each time. Two different types, it will get two different you know or it gets different data, I can say. So how come it is possible if a transaction is reading a row twice, it gets different results both times? That means it gets different state each time. First it reads, it gets some data, the same row. If it reads right, if it reads twice, it gets you know the data which is different each time. The raw data is different each time. So how is it possible? Some other row might have modified this. Some other transaction in between might have updated this row here, right? Some other transaction might have updated this row in between. Yes, that might be the reason here. Okay, you got this point here. So each time the transaction reads the data twice or row twice, same row twice, is different results because the transaction might have been that another transaction might have updated that row here. Another transaction might have updated that row. Yes, that's the reason. There is a possibility. Yes. So how this issue will address the transaction? How the issue will create a problem for the transactions? What do people think? How this issue will create a problem? Unrepeatable read issue. How it creates a problem? So I'll give you an example for this. Okay. For suppose you might have done this. Let's say you're trying to make a payment online. Let's say you did some online shopping and you're trying to make the payment through your account. You're trying to make the payment through your account. Okay. Yes. You know, the bank application will show you people the balance before you confirm. So it will ask you, let's say your balance is 5,000 and you're supposed to make a payment of 4,000. Here, after you made the payment here, sorry, once once you have logged in into your bank application, it was showing the balance as 5,000. So you got enough balance, right? You would like to make the payment of 4,000, let's say. So you'll find that okay, you got enough balance in the account. You got enough balance in the account here. Yes. But you see, once you try to confirm that payment, so again you'll get a message that your transaction has failed because you don't have sufficient balance. So your balance shows up as only 2000, let's say. Why so? Because in between some other transaction might have updated this account's balance, might have drawn some amount from this account, from the same account. Maybe you see you got a EMI, ECS, automatic payment, ECS mode. You know that, right? Your EMI or some loan might have been drawn from your account. So this can be an issue. So how do we address this unrepeatable rate? Now that's the question. How do you address this unrepeatable rate? Yes. So you know we can use an isolation level, okay, called as repeatable rate. We can use an isolation level called as repeatable rate. Okay, actually I didn't show you people how to set the isolation for level for read committed, right? So if you want to set the isolation level to read committed, you see this property value should be 2. This property value should be 2 here. Okay, yes. Okay, next, so to set the isolation level to repeatable rate, you use this value 4. For repeatable rate, the value is 4 here. Yes. Okay. Now, how this repeatable read will address this issue. Let's see. Unrepeatable read issue. We'll see. In this case, what happens is reading transactions block writing transactions, but not other reading transactions. And writing transactions block all other transactions. So a reading transaction blocks writing transaction. Okay, yes. Next, hope you people got it right. So you see in between a transaction which is reading the data, so it will avoid all other transactions from updating that row. Yes, this way the issue can be addressed. Next we got phantom reader. Phantom read. So this is the last isolation issue. Okay, phantom read. So phantom read you'll find that it is similar to unrepeatable read. It is similar to unrepeatable read. It is similar to unrepeatable read. In case of unrepeatable read, we are only talking about one row, a particular row. When a transaction is reading a particular row twice, you got different results both the times. That means once you read it, you got one row. Again, the same row you're trying to read it again. This time the row data is different. That was unrepeatable. Phantom read also is very much similar. You'll find that in case of phantom read, we'll be talking about multiple rows. That means if a transaction is reading a set of rows, it gets two different results twice. Transaction is reading set of rows. Okay, yes. Okay, you'll find that phantom read means it deals with set of rows. A transaction is reading multiple rows. Each time it or twice it is trying to read multiple rows twice, it gets two different results. Let's say first it executed a query, it got 10 records. Second time it executes it, it gets 15 records. So in between, another transaction might have added some more rows here. That means in a table, from a table, let's say you're reading all the records. First time you got 10 records, second time you got 50 records, so 20 records, let's say. In between, another transaction added 10 more records. So that is phantom read problem. So in between, other transaction is updating that rows or adding some rows. So how to address this issue? You see, it is not related to specific row, a particular row. Okay, yes. So it is related to multiple rows or a table, I can say. So far the issues which you saw were just row level. That means only one row. But now phantom read deals with multiple rows. So to address this issue, we need to set the isolation level to serializable. Serializable, yes. So serializable is the strictest isolation level, I can say. You'll find that a reading transaction or writing transaction will not allow any other transaction to read or write. A reading transaction or writing transaction will not allow other transactions to read or write. Okay, yes. Reading transaction or writing transaction will not allow any other transaction to read or write. Yes. So hope you people got it. Yes. So this is the strictest isolation level which you can use to address that issue. Okay. So now if you want to set this isolation level, then you see you need to set this property value to 8. Serializable isolation level. You want to set the isolation level to serializable. Then you will use this property value. You set the property value to 8. Yes. Okay. That's it. So this is about the transactions. So the last thing here which is left over in the Hibernate is caching. So we'll talk about it on Monday, and I'll start with Spring also on Monday. But we have a class tomorrow at the rate 8 a.m. Central Time. So from tomorrow your class you have daylight saving, right? But still the class will start at same time, 8 a.m. Central Time. The class starts at same time. Okay. Tomorrow I'm going to talk about a different topic, a weekend special class. Even the meeting link will be different. So I'm going to talk about JavaScript and the Ajax. Okay, JavaScript and Ajax. So I'll mail you the meeting link, tomorrow's special class meeting link. So use that meeting link to join the class tomorrow. Only special class. Okay. Yes. Fine. So I'll stop it here today. Let's meet tomorrow at 8 a.m. Central Time. So we'll be having the special class of JavaScript and Ajax. Yes. That's it. Thank you. Bye bye.